All right, so this is the last part of section 1.5. It's the word problem part of it. And there's both an even and an odd problem on this page. You're going to do problem 25 after I do problem 26. I think these problems are exactly or more or less the same as what we did in section 1.4, except at least the wording of the problem up here is the same, and the parts are a little bit different. So part A of each of our word problems is asking us to find a derivative, and that's what we've been doing so far. And part B is evaluating the derivative at a number and interpreting exactly what that means. And that's going to be a little bit different because in a word problem, the interpretation of what a derivative is a little bit more precise than in a non-word problem. So for part A of 26, I need to get 2 points to find a derivative. So I'm going to work on that first. So for 26A, usually my x coordinate is x, but because in the x position I have t, which stands for time, and maybe I should read this problem quickly before I jump into it. A baseball is projected upward from a ground level with an initial velocity of 64 feet per second. Its height is a function of time given by s of t equals negative 16t squared plus 64t. So how this function worked in section 1.4, it's going to work the same. If I put a value for t, which is a time in seconds, what I get out is the height of the baseball in feet. So each point is going to have a time in seconds and a height in feet. And when I go to do the derivative, well, I'll talk about that after I get the derivative done, what the derivative is measuring. So my first point has an x coordinate of t and a y coordinate, that's the function value itself. My second point has to have an x coordinate of t plus h, and its y coordinate's going to be what I get when I plug t plus h's in for the t. So it's going to be negative 16 times t plus h squared plus 64 times t plus h. T plus h squared is just like x plus h squared, so it's going to be t squared plus 2th plus h squared. So this is going to give me negative 16t squared minus 32th minus 16h squared, and then plus 64t plus 64h. So the y coordinate of the second point is negative 16t squared minus 32th minus 16h squared plus 64t plus 64h. So the derivative, s prime of t, is going to be the limit as h goes to 0 of y2, which is this horrible mess, negative 16t squared minus 32th minus 16h squared plus 64t plus 64h. That's y2, and then minus y1. And then when we do the minusing, instead of putting the parentheses in, we'll just change the signs. So it's going to be a minus a negative 16t squared, which will turn into a plus 16t squared, and then a minus 64t. All over x2, t plus h, minus x1, t. Now in the numerator, the minus 16t squared and the plus 16t squared cancel. The plus 64t and the minus 64t cancel, and in the denominator the t's cancel. So I get s prime of t equals the limit as h goes to 0, and what's left in the numerator is minus 32th minus 16 h squared plus 64h all over h. I factor out a common factor of h in the numerator. I get s prime of t is the limit as h goes to 0 of h times minus 32t minus 16h plus 64 all over h. And now I cancel out the h's. I get s prime of t equals the limit as h goes to 0 of negative 32t minus 16h plus 64. Then I plug in 0 for h. I get minus 32t minus 16 times 0 plus 64. So the derivative, s prime of t, is going to be minus 32t plus 64. Oh, I'm getting tired of doing those, so you've got to be too. So that's my answer to 26A. 26A says find s prime of t. S prime of t is negative 32t plus 64. Part B, the easy part is to find s prime of 2. S prime of 2 is going to be negative 32 times 2 plus 64, which is negative 64 plus 64, which is 0. I don't know if I can find it quickly here. I'll give a go at finding this in section 1.4 when we did it. I don't know what I can find here so quickly. That's being not so good. Maybe I'm getting close to it. Sorry for this. You don't need these delays in my videos. They're long enough without my delays. I'm not finding it that easily. It's taking me another 5 minutes to find it. So now I need to interpret this. Well, the function itself, if I graph it, we did this earlier when we did in section 1.4, the x-axis is the time and the y-axis is the height in feet. And when I graphed the function when I did the same function in section 1.4, I did y equals and then graph the function negative 16x squared plus 64x. I can't use the t. And make my windows to accommodate the height and the time. I think the window that we used was 0 to 10 on the x's and like 0 to 100 on the y's. And what it does is it shows the flight of this ball, and at 2 seconds its height is up here. If I do second calc value 2, at 2 seconds it's at 64 feet high, and it was right at the top of it at its maximum height. And what happens with this baseball is it starts at 64 feet per second and it slows down, and eventually for an instant it stops, gets to the top, and it starts going back down, and as it goes back down it's speeding up. So while it's going up it's slowing down, it stops, and then it goes down and speeds up. Right at the top it's not even moving at all, and that's what's happening right here. At 2 seconds, this 2 means 2 seconds, it's moving at 0 feet per time in seconds. So what the derivative of this is called a position function. When a function, when the x's represent time and the y's represent a height or a position, the derivative gives you in the instantaneous velocity, the instantaneous rate of change is its velocity in feet per second. So when we calculate the derivative, the units for the derivative in a word problem are always what the y-axis represents per what the x-axis represents. And the graph of this function that goes through the point 2 comma 64 that has a slope of 0 there. The units for the derivative are feet per second. So when I did my computation, I found s prime of t and got 0. I had to say more than the instantaneous rate of change is 0 or the slope of the tangent line is 0. And what I did to improve upon it is I attached units. I attached the units from the axes of the graph. And very specifically, the time is given in seconds and the height is given in feet. So the y-axis is a feet, the x-axis is the time, the units are feet per second. We did that when we did section 1.4. You may not remember it perfectly, but we did it. So you should make the same effort that I did on problem 26 to do 25. First step is going to be to find the derivative, finding 2 points, and then doing the limit. And then interpret what s prime of t is. And it's going to be very similar. Your s prime of t, it's going to be its speed, but it's going to be not in feet per second because it gives it its height in meters per second. So when you do your s prime of t and you interpret it, you're going to get a number by plugging 2 into the derivative, and it's going to be its speed in meters per second. All right, so I'll move on to the page that has 27 and 28. And we did this problem again. You did 27 in section 1.4, except we didn't find a derivative, but we worked with the same scenario. So the word problem for 28 says a cannonball is dropped from a building, and I drew a picture like this. The cannonball was dropped from a building, and eventually it goes down and it hits the ground. For this particular function, the height of the cannonball in meters, so the y-axis represents the height of the cannonball in meters, given after t seconds, so the x-axis represents seconds, is given by this horrible function. So the derivative, when I go to find part B, when I plug 1 into the derivative, it's going to give me its velocity in meters per second. So part A, I don't need to throw any units into part A. I'm just going to do a generic derivative. But in part B, when I plug 1 into the derivative and get a number, when I go to interpret it, it's going to give me the velocity of the cannonball in meters per second. So I'll go on and I'll do part A. I'm going to find f prime of t. And in 28, to do part A, I need 2 points. The first point is going to be t comma negative 4.4 t squared plus 50. And the second point is going to be t plus h comma, and I have to figure out what the comma is by going negative 4.4 times t plus h squared plus 50. That's going to be negative 4.4 times t squared plus 2th plus h squared plus 50. And then I'm just going to multiply this out and throw it up there. So negative 4.4 times t squared is negative 4.4 t squared. Negative 4.4 times 2th is negative 8.8 th. And negative 4.4 times h squared is negative 4.4 h squared, and I still have the plus 50. So I've created my 2 points, and now I can find the derivative. F prime of t equals the limit as h goes to 0 of y2, which is this horrible mess, negative 4.4 t squared minus 8.8 th minus 4.4 h squared plus 50, and then minus y1. I'm going to change both of these signs. Minus a negative 4.4 t squared is going to be a plus 4.4 t squared, and a minus 50 is going to be a minus 50. Over x2 minus x1, which is t plus h minus t. In the numerator, the negative 4.4 and the positive 4.4 t squared cancels. The positive and the negative 50s cancel. And in the denominator, the t's cancel. The only thing left in the numerator are those two terms that have h's. I'm going to factor out that h just to save a little room. So I'm going to get the limit as h goes to 0 of h times negative 8.8t minus 4.4h. That's just taking the h away from each of those. And in the denominator, I just have an h. I'm going to cancel out the h's and get f prime of t equals the limit as h goes to 0 of negative 8.8t minus 4.4h. I'm going to plug in 0 for h and get negative 8.8t minus 4.4 times 0. And that's just going to be negative 8.8t. So that's what f prime of t is going to equal. That's my answer to 28A, and that's the grungy part. I'm kind of done with the grungy part. I'll move on to the easy part. So the answer for 28A, f prime of t equals negative 8.8t. Part B wants me to find f prime of 1. F prime of 1, which would give me a slope of a tangent line, would be negative 8.8 times 1, which is negative 8.8. And what that is the velocity of the cannonball after 1 second is negative 8.8 meters per second. The negative means it's falling as opposed to going up. If I want it to be a little more wordy with my answer, I can say the velocity or the speed of the cannonball at 1 second is 8.8 meters per second. And if I put a negative, that would show to me that it's going down as opposed to getting higher. All right, so your problem 27 is exactly the same style of problem. The first thing you're going to do is find s prime of t by finding the 2 points and finding the derivative. And then your interpretation is going to be very similar because this pebble that's being dropped has a height in meters and the times in seconds. When you have a height in meters and a time in seconds, the derivative is going to give you a velocity or a speed in meters per second. 29 and 30, we lived in section 2.4. 29 is selling car seats, 30 is selling cell phones. And very specifically, if I read through the question in problem 30, this function gives me the profit from selling X cell phones. So in terms of a graph, the x-axis represents the number of cell phones sold. So the profit from selling X cell phones is given by the formula. The profit is going to go on the y-axis. And when I go to do part B, what the derivative is going to give me is the profit per cell phone sold. So it's going to give me the profit, which is the coordinate of the y-axis. And then I use the word per, and then cell phone. What the derivative of a profit function is a marginal profit function. So this p prime of t, the derivative of a profit function, we call the marginal profit function. And it's going to estimate the profit by selling when I sell the next cell phone. So p prime of 1,000, what it's going to estimate is the profit for selling the 1,001st cell phone. So my best answer to part B in words is going to be, I'm going to estimate the profit when I sell, or when the 1,001st cell phone is sold, because it's giving me the profit per cell phone. When 1,000 cell phones are sold, that's going to give me the profit of the 1,001st cell phone. So now the grungy part is calculating this derivative. When we get to chapter 2, we find shortcuts to find the derivative, which are so much nicer than what we're doing right now. So to do part 30a, I'm asked to find a derivative. I need 2 points. The first point has x coordinate of x and a y coordinate of the function. Second point has an x coordinate of x plus h and a y coordinate that's going to be a horrible mess. So I'll do it off to the side here. It's going to be 450 times x plus h minus 0.055 times x plus h squared minus 300,000. First parentheses I'll leave for a second. I could clear it right now if I cared to. I want to get rid of the exponent first because that has a nasty decimal in front of it. X plus h squared is x squared plus 2xh plus h squared. Now I'm going to get rid of the parentheses. First parentheses I get 450x plus 450h. Next parentheses I get negative 0.055x squared. And I'm not sure what when I multiply 2 times this, I'm going to do it off screen. So I'm going to go 2 times negative 0.055 and I get 0.11. So this is going to give me minus 0.11xh, and then this last multiplication is going to be minus 0.055h squared, and then this minus 300,000. Nothing cancels or combines there. That whole string is my y2. So my y2 is going to be 450x plus 450h minus 0.055x squared minus 0.11xh minus 0.055h squared minus 300,000. That's pretty insane. Sorry about that. So the derivative p prime of x is going to be the limit as h goes to 0 of, first thing I need is the y2, so it's going to be 450x. I'm tired of writing this, but I'll do it. Gosh darn, it's long. And then I need to go minus y1, and I don't have room to put it horizontally. I'm going to stack these right where they need to be stacked. So right here I'd put a minus 450x. I'm going to line it up under that 450x because it's going to cancel. And then that sign's going to flip to a plus 0.055x squared. So instead of writing it off the screen, I'm writing it above the things they're going to cancel with. And then that is going to turn to a plus 300,000. So that's the numerator written kind of as best I can write it right here, over x2 x plus h minus x1 x. Things without in the new x's cancel, and in the denominator without the h's cancel, and then in the denominator the x's cancel. So I'm going to be left with p prime of x equals the limit as h goes to 0 of 450h minus 0.11xh minus 0.055h squared all over h. I'm going to factor out an h and cancel my h. So I'm going to get p prime of x equals the limit as h goes to 0 of h times 450 minus 0.11x minus 0.055h all over an h. It's what happens when I take the h away. Cancel the h. I'm left with p prime of x equals the limit as h goes to 0 of 450 minus 0.11x minus 0.055h. And now I plug in 0 for this h. I get 450 minus 0.11x minus 0.055 times 0. That piece goes away. I'm left with p prime of x equals 450 minus 0.11x. All right, so there's my answer to 30A. 30A gives me p prime of t equals 450 minus 0.11x. That's the derivative. That's the formula for the instantaneous rate of change. Now I'm going to do part B. I'm going to plug 1,000 in for this. So p prime of 1,000 is equal 450 minus 0.11 times 1,000. That's going to give me the slope of the tangent line, or the instantaneous rate of change, or the profit when we sell the thousandth and first cell phone. It's the marginal profit function. So now to do this, bring out my calculator. I'm going to go second quit, clear. So we go 450 minus 0.11 times 1,000. And I get 340. And it's going to be dollars per cell phone. So technically, it's my profit, my instantaneous rate of change is $340 per cell phone. That's the profit that I'm making per cell phone after I've sold 1,000 cell phones. And so it's right to say that we're going to estimate the profit. The profit will be $340 when the 1,000th and first cell phone is sold. All right, so now you can make a crack at 29, and we're almost done with this section. Just need to do one more word problem each. Well, you'll have two because you need to do your problem 29. And I'll move on to do 32, which isn't near as grungy as 31. So 31 and 32 both give me a cost function. The cost function in 32 tells me how much it costs to produce X books. And so graphically, the x-axis is the number of books that I produce, and the y-axis is the cost. So the derivative when I do question 20 is going to give me the cost per book. So it's going to be the y-axis, which is the cost, per the x-axis, which is the book. And when I find c prime of 20, it's going to give me the cost of the 21st book. The derivative of a cost function is the marginal cost function. So this c prime of t, we're going to call, it's going to be called a marginal cost function. And it estimates the cost per book at the specific production level. It's going to estimate the cost of the 21st book. So when I get the number for problem 20, I'm going to say the cost of the 21st book will be, because that's what c prime of 20 is going to give me. So now I just need to go through and do the math. Parts A should probably say find c prime of x and not t. Similarly, yours should say find c prime of x and not t, because there's not t's there. So for part A, to do the derivative, I need 2 points. The first point has an x coordinate of x and a y coordinate of x squared plus 30x plus 50. Second point has an x coordinate of x plus h and a y coordinate of x plus h squared plus 30 times x plus h plus 50. And that's way easier than the last one. X plus h squared is x squared plus 2xh plus h squared. 30 times x plus h is plus 30x plus 30h, and plus 50 is plus 50. Those are my 2 points. And now I'm going to find the derivative. So c prime of x equals the limit as h goes to 0 of y2, x squared plus 2xh plus h squared plus 30x, should be plus 30h here, plus 30h plus 50, and then I have to go minus x squared, which I'm going to write up here so you can see the canceling, minus 30x so you can see the canceling, and minus 50 for the numerator. That's my y2 minus y1 written a little bit oddly just so you can see the canceling, and because I was running out of room there. And then the denominator is x2 minus x1. So for my next line, I'm going to get c prime of x equals the limit as h goes to 0. The x squareds, the 30x's and the 50's are going to cancel. I'm going to get 2xh plus h squared plus 30h, and then all over h. I'm going to factor out an h. You get c prime of x equals the limit as h goes to 0 of h times 2x plus h plus 30 over h. Cancel the h's. I get c prime of x equals the limit as h goes to 0 of 2x plus h plus 30. Now I plug in 0 for h. I get 2x plus 0 plus 30, which is 2x plus 30. That's the hard work. That's the answer to part 32a. The c prime of x, the marginal cost, or the derivative of the cost function, is 2x plus 30. So for part A, c prime of x equals 2x plus 30. For part B, let's find c prime of 20. C prime of 20 is going to be 2 times 20 plus 30, which is 40 plus 30, which is 70. And interpret my answer, we can say at a production level of 20 books, the cost per book is $70 per book. Or better yet, we can say the cost of the 21st book is going to be about $70. Just like in the last problem, the profit from selling the thousands and first is going to be, so when you take the derivative of a cost function and put a number in, it estimates the cost of selling the next book. When you find the derivative of a profit function and put a number in, it estimates the profit from selling the next unit. Alright, so you should be able to give 31 a stab, and that's everything that we need to know for the section. Now we just need to sum everything up in our review section. So the next section, there won't be anything new in. It's going to be a review for the test. If you can do every problem on the review, then you should be able to do every problem on the test.